Okay, Algebra 2, this is notes 12.3.1. Write explicit equations of geometric sequences. Pause the video, write this down. And on this first page of your notes, this is just some definitions that actually we've already covered in previous lessons. We talked before about how to tell the difference between arithmetic and geometric sequences. And now what we're doing is we're getting ready to study some specific equations about geometric sequences. We've already covered arithmetic. So again, pause the video, write this down. Here we have the general form of an explicit equation of a geometric sequence. And here's our first problem. And I'll demonstrate this in a sec. All right, so our first job is to write the explicit equation, okay? So here we've got the general formula for the explicit equation. There are two things we have to plug into this. We have to plug in a sub 1 and we have to plug in r, okay? I'm gonna write down a formula for finding r. We're gonna find r by taking the second term and dividing by the first term. So you might remember when we studied geometric sequences before, we said, well, what number do I need to multiply by the first term to get the second term? All right, we did that before. What number do I need to multiply with 3 to make 15? The answer is going to be 5. The common ratio is 5. But if you're ever stuck where it's not easy for you to figure that out, we're just going to take our second term, which in this case is 15, and divide by our first term, which is 3. So 15 divided by 3 is 5. Our common ratio is 5. 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is 375. So that's, again, what a geometric sequence is. For each new term in the sequence, you're multiplying by a constant number, which we call the common ratio. So our common ratio is 5. We also need our a sub 1. Let me zoom in on this formula here. So I'm going to erase because I don't know if you can see. There we go. So we also need to plug in our a sub 1. And then we will have our formula. So our a sub 1 for this problem was 3. And then once we plug those two numbers in, we have the explicit equation of the geometric sequence. Let's do that now. So our explicit equation is going to be a sub n equals a sub 1, which is 3, times the common ratio, which is 5, to the power of n minus 1. And that's the formula, okay? The formula has a sub n and n in it, all right? That way you can find any term by using that formula. The second part of our problem is to find a sub 7, to find our 7th term. So now we're going to plug 7 in for n. So I'm going to have a sub 7 equals 3 times 5 to the power of 7 minus 1. And again, it's been a while since we did this, but since that 7 minus 1 is all small in superscript, there's an understood grouping symbol around them. In other words, you're going to do this as if there were parentheses around this. You're going to do this first in your order of operations. So 3 times 5, and then 7 minus 1 is the power of 6. And then the next thing in our order of operations is we're going to evaluate the exponents. So 5 to the power of 6 is 15,625. And then finally multiply by 3. 46,875. So our seventh term is 46,875. A couple of side notes I want to point out, okay? Geometric sequences, put this in your notes, please, have explicit equations that are exponential. Okay, so let's look at this explicit equation. So here, my variable is in the exponent. That's called an exponential equation. Okay. Exponential equations get very big very fast. Okay. You may have commonly heard the expression, something increases exponentially. It gets very big very fast. Coronavirus grows exponentially. It gets very big very fast, or it has the potential to if there isn't social distancing, okay? And so that's going to be important as we go into the next thing that we're learning. Just the concept that exponential equations get very big very fast. Geometric sequences get very big very fast. And so it's not unusual. See how big our answer here is for the seventh term, 46,875. It's not unusual to get big numbers when you are finding a particular term in a geometric sequence. Next problem, write this down. All right, so we need our a sub 1 and our r. So our a sub 1 is 10. Our r, our common ratio, the number that we multiply each term by to get each new term, okay, is going to be, let's take our second term divided by our first term. So our common ratio is 3. To get each new term, we're multiplying the previous term by 3. So now I'm ready to write my exponential equation, or maybe I should say the explicit equation for this geometric sequence. That's a sub n equals a sub 1, which is 10, times the common ratio, which is 3, to the power of n minus 1. Put a block around this because this is the first part of your answer. You're asked to do two things. You're asked to first write the explicit equation, and that's what I just did. I put a block around it. The second thing we're being asked to do is to find a sub 12, to find our 12th term. So now I'm going to plug 12 into that equation. So I have a sub 12 equals 10 times 3, and then we're putting 12 in for n to the power of 12 minus 1. And again, remember, you are first simplifying what's in that exponent. So 12 minus 1 is 11. And then we're going to do order of operations. So exponents happen next. So I'm going to do 3 to the power of 11 next, which gives me 177,147. And then I'm going to multiply that by 10, which is 1,771,470. Okay, and like I said, it's not unusual to have very big numbers when you're finding a particular term of a geometric sequence. All right, that's it for that video.